Well, Professor Clements back with you, talking about electromagnetic waves. And this session will concentrate on the electromagnetic spectrum. The electromagnetic spectrum. This chart is all we're going to use basically for our discussion here. A few more slides, but this is the main content. And our spectrum, we're going to start over here on the right with the gamma rays. The gamma rays are the most energetic form of light. And I should tell you right now, when we think of light, we think of red, orange, green, blue, so forth, yellow, visible light. That is too restrictive. The word light refers all the way from radio waves to gamma rays. So the gamma rays, very high energy, penetrate into our skin, emitted by the nuclei of atoms is a common way that a gamma ray is produced, but very energetic. They have high frequency. Because they have very high frequency, they have very short wavelength. And light of different wavelengths interacts with matter in different ways. The gamma rays are able to penetrate. They can ionize atoms, carry a lot of energy. The next step down would be X-rays. And X-rays are also very energetic and can ionize matter. Just not quite the same frequency as the gamma rays, a little lower frequency, meaning they have a little less energy, and they have a little bit longer wavelength, but X-rays. And then ultraviolet, beyond the violet, shorter wavelength than violet. We have ultraviolet, still can be damaging, can give you a sunburn, and can ionize atoms, which makes them dangerous for biological systems. But ultraviolet light, less energy than the X-rays, right on the border of violet light. So here we have our visible spectrum. You can see the visible spectrum is a small portion of the full electromagnetic spectrum. But we have violet, blue, green and yellow, orange and red across here, red being on the left, colors that we can detect with our eyes. And we have technology now from in the 1900s that was developed to detect ultraviolet, to detect X-rays, to detect gamma rays, and to detect infrared. Beyond the red, longer wavelength than the red, we have infrared. We're getting into low energy now. Beyond the infrared, microwaves, television, radio, long wavelengths. If you look here, 300 meters, 100 meters is a city block in the United States, roughly. So 300 meters out here for this particular segment of the spectrum. But the electromagnetic spectrum all the way across here. And some interesting things involving the Earth in terms of the spectrum. The sun gives off most of its energy in the visible range. So it's good for us that our atmosphere is pretty much transparent to visible light. About 70% of the sun's energy reaches the surface of the earth and gets absorbed. About 30% is reflected by clouds and snow and ice and water and so forth. But about 70% of the solar energy is able to get here and warm up the surface of the earth. The Earth emits in the infrared part of the spectrum. The Earth is sending energy out into space, and the infrared, this light is captured somewhat by our atmosphere, especially if there are clouds present. So in the winter, the nights that are coldest are the clear nights. Clear and cold would be the weather forecast. If the sky does not have clouds, more of the infrared is able to get back out into space. If the sky does have clouds, then the infrared is captured by the clouds and re-radiated back to the surface of the earth. The clouds act something like a blanket. There is a greenhouse effect active for the earth, and that greenhouse effect does raise our average temperature from what we would have without the greenhouse effect. I think it's something like 40 degrees Celsius, which is fairly significant if you consider temperatures throughout the year. But the greenhouse effect effect that is in place right now is useful for us. If the greenhouse effect would become a runaway greenhouse, our temperatures could raise by several hundred degrees in the extreme case. But just a little bit of temperature increase can be a concern for melting polar ice, raising ocean levels, and changing habitats. So it's something that still needs to be studied and to be cautious with. We should take care of our environment. We're not going to go into much of the details there about the greenhouse effect, but we have one right now. It's useful. And it occurs because infrared light is captured in our atmosphere and sent back to the surface of the Earth by clouds and by greenhouse gases, carbon dioxide, and water vapor, and so forth. Methane. So we won't talk about that anymore. Let's go ahead and talk about ultraviolet light. Again, short wavelength can ionize atoms and disrupt the operation of molecules. And certainly want to use sunscreen to protect your skin out in a bright sunny day in the summertime. You also need to be aware our atmosphere has some protection for us for ultraviolet light, the ozone layer, and there's been some reduction in the ozone layer due to chemicals released in our atmosphere from aerosol sprays and other chemicals. So you might hear the ozone hole being talked about. There's been a thinning of the ozone layer, so more ultraviolet light can reach the surface of the Earth, and that can be a problem for people. Your skin does pick up solar energy, light, and produce vitamin D, and that's variable in how much sunlight you get, winter versus summer. So producing less vitamin D in Nebraska anyway in the winter, where there's less sunlight available, is a condition. The X-rays, again, X-ray machines. So you perhaps have a dental X-ray or X-ray in a doctor or hospital office. These X-rays are produced by bremsstrahlung. When an electron slams into a piece of metal, it's decelerated, it slows down. Now that acceleration produces X-rays as the high energy electron gives up its energy to light. It's an interesting effect. So let's go on to another slide here, if we can activate this. We cannot see the surface of Venus because it's continually covered with a very thick layer of clouds, but we can quote-unquote see the surface of Venus using radar. So the microwaves can pass through clouds. The evening news will have a weather report in the summertime, have radar active to pick up where the storms are. That radar signal is passing through clouds. Not quite the same here. The radar is bouncing off rocks on the surface of Venus, but Venus has been mapped out. There are craters, there are volcanoes, some which may be active on the surface of Venus. But Venus has this runaway greenhouse effect continually about 800 degrees Fahrenheit on the surface of Venus. The clouds are so thick, infrared has a very hard time getting out from the surface of Venus. And here the dental X-ray, giving the dentist good knowledge of the structure of the bones of your teeth and helping the dentist take good care of you. And there's protective shielding over the body here, lead apron, to in case there are any stray X-rays to minimize exposure to the body. So there's a little discussion of the electromagnetic spectrum. Again, light refers all the way from radio to gamma rays, and it's not restricted just to the visible spectrum. The electromagnetic radiation reacts in different ways for the body and other materials based on really the frequency or the wavelength of that electromagnetic radiation. Causes a different transmission property, reflection property, penetration property for that light, and has been used in successful ways in the medical field and also in science and astronomy. We now have telescopes orbiting the Earth that can detect gamma rays and X-rays and ultraviolet and infrared and help astronomers learn a lot more about the universe by studying processes at different wavelengths of light. So keep reading, and we'll be back again with another lecture soon.